Hey guys, it's Vince. Today in this video, we're going to be taking a look at an instructional video on how to solder. This is interesting because there are many videos, as I'm sure you know, online that talk about soldering. And again, soldering for oneself is different than soldering for someone else where you're actually selling your work. Let's jump right in and we'll cover best practice along with what not to do.
I'm going to move up to a nice clean set of holes here, there, and I'm going to put a great big mass, a mass of this flux on these holes, heaps and heaps and heaps. And the reason I'm using so much is because I do want to demonstrate this point.
Well, right away we see that the content creator is applying the proper flux, and he is in this case working on a circuit board. Now guys, I don't do a lot of PCB soldering. I would recommend any channel that is actually doing commercial grade soldering. What do I mean by that? I'm talking about channels that have content creators like Louis Rossman who is actually selling a product that they're using soldering on to complete. That is a huge difference than guys showing you what they claim to be professional soldering or soldering techniques, in which case this is what they've become accustomed to. Very few content creators actually understand professional level anything unless they are selling their work, because they are no longer the critic, their clients are. Think about what I just said.
Now I'm going to grab, wrong soldering iron, sorry. I'm going to grab a whole stack of solder like this onto the end of the soldering iron. And I'm now going to do the same thing I did last time. I'm going to run them across here. And what you can see what happens here when I'm using that flux is we've ended up with a row of really nice, neat little blobs rather than this kind of smeary mess that I ended up with before.
The content creator applied the flux properly to the circuit board to be soldered. Where things went crazy is when he shows his audience, once again as an instructional video, to just wave the iron across the circuit board, covering numerous traces. So much so that we see solder has actually gotten on traces he wasn't meaning to solder. Why would you want to show your audience that if you're instructing? As a matter of fact, you'd want to clarify that, because the whole goal here is not just to apply solder everywhere. It's to apply it just to the components and just to the area of circuit board that you're planning on joining those components. In this case, if you're actually just going to tin the traces, you want to go through and make sure that you're applying the flux just as precise as the solder, because what you guys just saw here is very interesting, and I hope you're all paying attention. You realize that the solder, even though he moved his iron quickly, stuck to all of the traces that had the flux when the heat was applied. You'll notice that flux spreads when heat is applied. Again, he's using more like a jelly format. It's a paste, but that gelatinous format will spread as heat is applied. In doing so, you could see wherever that flux made contact is exactly where the capillary action of the solder went, and boom, you've got that contact point. So again, be precise. Move slow. First of all, a soldering iron is extremely hot. There is no reason for you to be making abrupt movements. And if you watch Louis do soldering on circuit boards, his work is like art, because a lot of them are Apple electronics where we're doing really, really fine circuitry. He requires a microscope. And when you see that kind of precision, you understand he's not waving irons like this. Everything there is done with care. And I cannot emphasize that enough. Don't be in a rush. Take your time. And you saw right here, yes, flux is very effective. And yes, capillary action is indeed real, so much so you saw how fast it contacted the other traces. But we also see here, and he brings up a valid point, looking at the traces when flux is not applied, you can see directly what you're left with is just a blobby mess. So to more reiterate this point, I want to show you Louis doing it and discussing the benefits of using flux and, of course, his pattern of how he does it. It's very interesting. Let's check it out.
I'm going to show you under the microscope what happens when you try to solder without flux. So the flux is the stuff that burns away, right? So see all the smoke burning away? Okay, all the smoke is burned away. Now watch what happens once all that smoke is burned away. And I try to add it to something. Okay, do you see how instead of it being a nice joint, like on the top, it's sticking out? So check it out. This was a joint that was made by somebody using flux. This was a joint that was made when the flux is burnt out. See, it doesn't flow anymore. It's just like taking a booger out of my nose and shoving it onto the capacitor. So the top side is a joint that was made properly with flux. This joint is a joint that I made when I burned all the flux out. Now watch what happens when I add some fresh flux and touch that existing solder without adding any new solder. If I do this, it flows nicely and beautifully and then works. So that is what flux does.
All right, this is a great example of circuit board soldering for those of you that want to understand this process and do it in a way that is up to a professional level. You can see Lewis's contact point where he applied the flux in the proper amount. We have proper wetting. You could see how that solder literally became a chrome finish. When we look over to the image on the right and we see what not to do, and this is presented by this supposed content creator instructor, once again, you could see why we have the blobbiness, just as Lewis went through as well. If you burn the flux off, you're going to get that clumpiness where it actually is not flowing the solder. It more or less tracks the solder to connect to whatever it touches. So if you go to pull your iron away, it gives you tails. It makes big blobs. You can also see there's like a crystalline effect of the flux on that solder, meaning it's burned. Okay? Now I'm going to tell you guys something else that's fact. Use the proper flux, and that doesn't mean the cheapest flux. There's a lot of different fluxes on the market. I like No Clean. I prefer Kester. The reason I do is I get the results consistently with their products. I've used many over the years, MG Chemicals. I've used all the brands that are traditional, that are either bundled in lower quantities. And the issue when you find guys bundling in lower quantities, are they tampered with? Are they genuine? You find all kinds of consistency issues. With Kester products, I never have that. And I always get the same result of what you just seen there with Mr. Rossman. You can see that contact is just immaculate. That is what you guys are looking for. When you see gray or hazy type solder connections, as a matter of fact, you could see it on the top of Lewis's, and you can see the color disparity between the two. You could see that real chrome finish on the bottom, and then on the top it's got more of a hazy finish. That's because there's not proper wetting. So whoever actually is doing the soldering, or robot, it's applying flux, but it's in a very small amount and they burn it all off. You really want a little excess flux to keep that wetting where it should be, and that solder will once again flow as it should.
And obviously those blobs are much neater and tidier. Now I'm not necessarily saying that you do what I just did using loads and loads and loads of flux and nothing else, but it does demonstrate to you what a difference it makes when using flux when you're soldering, because of the way it halts that oxidization and helps that that solder flow and form into nice little blobs rather than sort of some big streaky mess.
These are some of the most interesting parts of content creator videos, when they try to explain something and they themselves are kind of uncertain of the process. He talks about the importance of flux in a way that's more of an option rather than it being critical. And realistically, all he had to do was pull up a Google search, explain why flux is important, removes oxides, promoting wetting, enhancing solder flow, and preventing reoxidation. But most of all, it helps create strong, reliable, and durable solder joints by performing several functions, which I just described. So again, we don't have to try to sound like we know what we're doing if we work with this tool on a daily basis. Once again, the people you want to learn from have to be vetted. And once again, when we just start putting up videos claiming that we understand a process, we should be able to describe that process at a level that's above average, because that's who you'd want to learn from, most of you. The real nice thing about soldering, like any other skill, is that you can't hack it. You either understand it or you don't. And if you do understand it, your connections will show it. If you don't understand it, it's very hard to relate to doing proper connections because you yourself haven't achieved that level of skill. And it takes time because you understand using in conjunction all the tools that we've discussed. Let's see how he does doing more connection.
Now I want to join these two wires together. Now you might just say, okay, we'll put those two wires together and dump some solder on them. That's generally not what I do when I'm soldering items like this. What I like to do first is I like to get solder on the two things that I'm planning to join, and then I melt them together. So let's start off with that. I'm going to just put this wire into the holder, and I am going to...
We see here that the content creator is now mounting his lead inside of a generic set of helping hands. And we notice, or should notice, that he doesn't have those helping hands protected with a piece of heat shrink over the jaws. So once you insert that lead within the jaws, and those metal jaws make contact with the casing, what do you think is going to happen, especially when you apply heat? Well, to take the guesswork out, I'll show you exactly what I'm talking about right here as I made a practical example. Now, this is part of a lot of practical examples I cover in this video, and it wasn't shot in direct order, but you'll get the picture exactly.
There's no more work involved. You don't see the alligator clip marks. As a matter of fact, if we did use a stay put and you're using the proper silicone insulators on it, you'll see you're not getting teeth marks. Okay, look at this. Let me show you something. Look at those teeth. Watch what happens when you apply this. You leave that and apply heat, and it's going to leave marks in our conductor. And there you go. You can see them right there. And I didn't even apply heat. If I apply heat, you'll see it even more. And these guys that are doing this and not understanding that you're supposed to put, I prefer silicone. If you don't have silicone, you can put heat shrink tubing over it to protect them, because we don't want to degrade our casing. You can see the marks it left right there. So again, details. Because trust me on this, and I cannot emphasize this enough, if this is heat shrunk, once again, and we do this right and heat shrink this, you will not have a problem. If an insurance inspector looks at this, this will pass. Okay? When you see conductor marks or any type of burn marks on your conductor, what do you think your insurance inspector would say, God forbid you ever had to call and make a claim? Because he's going to look at your electronics, especially if it's not something that is from a store. If it's not a retail piece of electronics, he would look at it. And I can tell you right now, if they find anything that looks out of place, and I mean anything, they're going to question it.
There we go, got that nice and in focus. I'm then going to get some solder onto this wire. All right, now, here's one of the most important parts of the technique. And this is the mistake that a lot of people make when they're first starting out with soldering. And the mistake they make is that they melt the solder onto the tip, and then they try and transfer that solder onto the wire. That is absolutely not the way to do it. What you need to do, and this is where that flux that's inside the solder is really important, because that flux that's inside the solder only works at the time that it's melting. So once you melt it onto your tip, that flux it's done its thing and it's of no use to you anymore. So you actually need to make sure that flux is being used when the solder is melting. So what you need to do, the correct procedure, is to use the soldering iron to get the wire hot. So this is, you're using the actual soldering iron to get the wire hot rather than melting the solder. Let me just clean this tip a little bit. It looks a little bit ugly. Okay, so I'm going to put him on there, and then what you do is you use the solder, then melt the solder onto the wire, not onto the tip. As you can see, that burning, that smoke coming off, that is actually the flux, and that's showing you that that flux is doing its job. And so as you can see now, that wire is completely coated with solder. Even if it is a little bit out of focus, it's completely coated with solder, and that's ready for us to do a join. So let's go through and do that one again with the other wire. So let's grab this second wire here, and just again, let's get that all nice and in focus as best as we can. Once again, soldering iron goes to the wire, gets the wire, tries to get the wire as hot as possible, and then melt the solder onto the wire. There we go. And then any excess that you end up with on the tip.
So the content creator attempts to make very clear that you're supposed to heat the conductors with the soldering iron and not actually heat the solder and carry over the solder when it's on the iron to the conductors to be soldered. This is what he claims. Now, what I want to make very clear, and I'm going to demonstrate this, is that we can already see here on what this content creator is illustrating for his audience as an instructional video that his casing is literally melted on his wire. You can see it's actually turned to liquid. And what's really interesting is that this is what he feels is best practice. No, sir. Let me ask a logical question. If you're to apply flux to a circuit board prior to applying solder, why would it be any different if you're working with a lead? That's a very good question. Let me tell you something in the way I work, and many of you I feel can relate to this. As I start working with a new project, whatever that may be, what I tend to do is formulate a pattern. And what I mean by that is I start documenting what I'm doing if it's going to be a project I plan on doing continuously. First, I do that for consistency. Second, I do it for efficiency. That means that I don't just do something because someone says this is best practice. I test. I keep testing until I get the desired result that I want. And doing so instigates learning. I want you to think about what I just said. And most importantly, I'm going to put my money where my mouth is, and I'm going to show you the difference between what we see here on burned casings and overheating conductors, and show you how the process is to be done by first applying flux to the conductor, and then after the flux has penetrated the conductor, then applying solder. What the content creator fails to make apparent to the audience is that minuscule amount of flux within the solder is not designed to join or tin components. It's just designed to give a slight cleaning effect and to also help adhesion to your iron's tip. And I can show you that, and I will show you that. And then you guys be the judge on what looks better, and not only looks better, is more logical. Let's jump right in.
So once again, we just got some leads here. This 16 gauge, nothing special. Got our Nipix auto strippers. Just going to go in and just do a standard. This is just one configuration, one click on this. It is approximately 6 millimeters. So just under 1/4 inch. I'm going to come in here and we're just twining these together, nothing miraculous. But I want to show you something because I still am getting lots and lots of questions on my soldering videos. Now, whenever I go to use my flux, best practice, you're going to find that your tip will usually be clogged, heated. And you see them little bubbles coming out. That means that now you shouldn't have any problem getting that liquid flux out. And there you go, 1 drop, 2 drop, everybody's happy. We're going to come over here. Soldering iron is at 650 degrees Fahrenheit. I'm just using my tip cleaner. Tip is clean. I'm just going to come in and watch this. Boom. Now it looks like I have a lot of solder there. Let me just turn my fan on. What I'm going to do, just hit another drop. And you see every time I go to solder, I'm always using flux. Watch how it levels. Boom. That looks totally different than when most content creators go to tin. Look at the thickness and look at how symmetrical that is. And that's all because of the flux. You can see how nice and level that is. If you're still not happy, you just add another drop or so. Let that flux get on there. And you notice the casing is not degraded. Done. And the reason it's not degraded, I'm using proper heat and I'm not cooking the conductors. And what I mean by cooking, you see these guys continuously leave the iron on the conductors because they sit there and they tell you, well, you're supposed to heat the conductors and then melt the solder. Well, let's think about that. The longer you do that, you're going to melt the casing. And they've actually represented that in their content creator videos. If you apply flux, you don't have to heat that long because the flux is doing the work that it's supposed to do. The amount of flux in this solder, which is Kester number 44, is not much, guys. It's just enough. And they say, oh, don't transfer it on the tip. Well, guess what? You can transfer it on the tip if you're applying the right flux to the component you're going to solder. Case in point, let's watch this again. All right, guys, in this demonstration, I'm showing you the new Magnalock with the stay put. Now, many of you are familiar with the stay put. Here's its base. I removed the stay put from its original base, mounted it in the Magnalock to give you a visual representation of how this jigging system works. You can see we have an IEC power port here jigged up. And again, our two red cylindrical type jigs are set to hold the tabs. And you can see that right here. And these you can adjust height on. And as you adjust the height, you're also screwing down that adjusts tension on these jigs. So if you need more tension, you can do that. If you need to adjust specific height, you can do that. And I know I have a lot of guys out there, and I always get told, you know, Vin, you do this for a living, so this jig and this tool makes sense for you. That's true, absolutely. But then they'll say, well, I don't want to spend that kind of money to do the kind of work you do in the sense that I'm only soldering sporadically. Or they'll tell me a hobby-based. Well, the bottom line is this. You need the right tools to do the right job. Just like you need the right flux to work with the right solder. It's a fact. So whether or not you invest in this, that's totally up to you. But once you see how this performs, I think it will enlighten you on what you've seen online. And this is why I've actually, out of Mother Invention, I needed it. So I designed it for myself. And so far, it's been a big hit. I've had a lot of guys asking questions, and that's why I'm incorporating in more of my videos. So once again, we got IEC mounted up. Everything here is set. I moved the stay put out of the way. And just so everybody knows, this is full steel. You can articulate in any position. And these are thumb screws, so you can adjust them. If they're in your way, you can just pull them out, and they lock like a socket. So you can then articulate once again wherever you need it, tighten it up, it stays out of your way, you're ready to go. So you're using one jig platform or the other, or incorporating both to get a simultaneous function. So once again, we get that synergistic effect of maybe a helping hand holding these. I'll show you that in a minute. All right, guys, now what I'm going to do is take the earth ground terminal on the IEC. I'm going to apply some flux. We're just going to do a little demonstration, applying it very liberally. Iron is still set at 650. I'm going to jump it up to 752 because this is a much larger conductor, and we're going to tin this. Tinning should be done on any component you go to solder. It's a must. And this is what I'm talking about is general assembly or wires. Typically with circuit boards, you're going to tin the boards, but when we're doing general assembly, wiring, you're always going to want to tin your components. And once again, we did that here, and you can see that chrome finish. Like I said, the light does not lie. That's how you have a quality finish. Casing is perfect, no degradation. We'll go in here now. Temperature on the iron is set. Once again, I have guys ask me, why do you use the solder ball first and then the cleaner? The main reason I do that is so I don't have to keep cleaning my cleaner as often. It also lets the brushes last longer. So again, just something to think about. Tip is clean, come over. Some solder. I'm gonna go with it. See how it leveled? It just leveled out, but you notice it did not cover that hole. So we'll add more flux. I'm reading what it's telling me. Come in, touch it, and done. Now you're golden, and if you notice you get a tail, just add more flux. It's okay to add it when it's hot. It'll melt right in, and done. That's it. Now look at that. And you can see exactly what we're talking about. Now we have two tin components, and you will come in here and you will be able to get a beautiful joint. When it come over again, you can see that the heat is still doing its job. It's cooling down now. Add a little flux. Flux on both of them. Now we're going to come in. I'm not adjusting my heat. We're once again doing a larger surface. Try to get that centered. That's it. Coming again, a little more flux. I'm not happy with the joint until I get a fill on each side. This is where feel comes in. Like that. Now, I don't know if you can see, you could see all of that brown. It's more of the rosin right there. We're going to remove that. Now this is no clean. However, I'm pretty picky on my connections. My clients expect that, so I clean everything. We'll come in here and we'll just, and you'll see, I'm just going to do one side just to show you a different variance of what you'll see. And you can see beautiful chrome finish. It's exactly what we want to see. I'm going to remove this. We'll just keep coming. And I like the citrus-based flux cleaners. Some guys like using alcohol. I'm not a big alcohol fan. And I've used it for years, and you just get tired. I get tired of the smell. This smells more citrusy, and I kind of like that. But it's all about cleanliness. The more that you leave this on here, and again, you notice I'm going backwards. I'm rotating the Q-tip backwards. So I'm never trying to grab any of the burr from the actual conductor. So if you go backwards, you're still getting in there. And you'll notice the Q-tip kind of molds itself more or less to the conductor. And there you go.
Okay, so I'm going to now put the wire. Let me just move this out of the way. I'm going to put the wire into this holder. I'm going to use both sides of this holder, of these alligator clips, so that I can hold both of these in position for soldering. Now, here we have two wires ready for joining. They've both got some solder on them, so I don't really need any more solder. But if I wanted to, I could just grab some here at the same time to melt them. And then I've grabbed the wrong soldering iron again. Let's try this one. And then we apply the heat to the area and then just melt those two together. There we go. Look at that. Okay, so obviously making sure that it cools. Don't pull them apart too early, otherwise the solder won't have cooled. But here you can see that that's cooled and it's solidified.
Now, I, like many of you, are confused because in the beginning of the video, he did use proper technique in that he used flux and then solder with the circuit board, fluxing the circuit board and then applying solder. Now what we've seen is him tin leads without using flux, and then on top of that, join the leads without using flux. And you can still see in this picture very, very clearly that both leads casing have been compromised because they've been melted. Now what I'm going to do is show you a practical application of doing this, and you guys can be the judge of which process works better. Let's check it out.
All right, guys, we already saw the content creator instructor try to show you how to join wires. Once again, he cooked the leads. Let me show you how easy it is. Once again, I'm going to give myself some more clearance. I'll move the stay put out of the way. I'll just loosen it up a little bit and just rotate it. Now we're good. There we go. Done. Okay, now I'll take my jigs and just slide them where I need them. Right here. Once again, these have silicone backing on both sides, so heat is not a problem. This one's already been tinned. We already did that. Just jig it. Done. Now we're going to come over here, and again, just do simple twining. And again, I always spin the lead. I don't twine. You have a lot of guys doing this. I don't do that. I always spin the lead. Done. Now we'll let the flux do the rest of the work. Put it back. And we're good. Down there. Fan back on. Again, a little more flux. Tin it. Done. Look at that. Solid. Okay. Come in again. Now, when a guy will message me and say, Vin, how do you get leads straight that are crooked? If your leads are straight, it's much easier to work. We all know that. If it's crooked, and you're dealing with wire that will not straighten, the easiest way to do it, and when I say not straighten, it's not going to straighten by you pulling. 16 gauge is not bad. If you're having problems heating, you heat the wire, and the PVC, once again, if you're using PVC cased wire, will relax. And it becomes softer until it cools. And it will allow manipulation much easier. So once again, we're going to come over here, rotate, put it in, right here. Now you'll notice, you want these leads to be exact. Okay? So when I say that, these are coming in dead on. I'm not twining. You see guys doing this, it's ridiculous. You don't need to do that. Once you solder this and using flux first and then soldering, you can see the finish we have. This will provide maximum amount of tensile strength. I just dropped the flux on there and you can see it liberally placed. Everything is set. I'm not doing anything. You could walk away, you could come back. That's exactly what we mean by jigging. Come in, clean tip, teeny bit of solder. Now these are already tinned, so they're going to merge. Watch. Done. That's it. And you can see what you're left with. See if I can rotate this guy a little bit. Rotate this guy a little bit. Do them together, and you can see exactly what you got right there. Clean it. That is the correct way. If we go back to the video and you guys pay very close attention, you'll notice he did not flux his joint. What he did was he tinned the two leads, then he just applied heat. No, we always use flux. And you can see when it's properly wet, that's what you're left with. Okay? That's exactly what you're left with. And you can see exactly how tight that is. Let me just see this real quick. I'll take the camera over myself. Just give me a second and let me focus on that. There you go. There's your joint. The casing, once again, is flawless. You can even see the reflection of my finger in the joint. That's what we're looking for, guys. Or I should say, that's what we all should be looking for. Here you go. Take the camera back. So again, I hope that this has helped. And we look at this. Look at the casing, guys. Look, nothing is degraded. Everything is perfect. We did not have any problems with pinch marks or burning. Everything looks as it should. Okay? That is the way a lead should look. Now, again, pulling this tensily, and we're going horizontal and trying to separate, you could easily pick up 10 pounds with this. Easily. The question is, once again, when would you be doing that with your electronics? You wouldn't. That's not what it's designed for. Yes, you want it to be strong enough to stay together, but once again, let's look at the application. This is what it's designed to do, is mend two conductors together, and that's exactly what we've done. Clean. That's exactly what you want. That's why, once again, having jigs, it makes it so much easier.
I sometimes use a hot air rework station that blows out hot air, or you can use a hot air gun, but you can just use a little Bic lighter if you want. So if I just grab this, just gently run the heat backwards and forwards over there, you can actually see that that is making that heat shrink down. It's also getting a whole stack of black burn all over it because I'm using a lighter. It's not the cleanest way to do it, but it does work. As I say, I would typically use a sort of a hot air rework station, and what that does is that shrinks that heat shrink down to size, and then once it cools, it then goes hard. And if we go back to our microscope, you can see that my lighter's melted my wire a little bit there, but the most important thing is that is now sealed.
One has to wonder why the content creator, after realizing he's burned the casing of the wire, would put this in an instructional video. Why would he put in a video at all that you're using a lighter when he openly says I have a hot air rework station with a heat gun to heat the heat shrink properly? Again, guys, these are legitimate questions. You can see the end result. Once again, we should not, as content creators, be rewarded if we're putting up videos that lead you into potential danger in terms of what application you apply these methods to. I can't emphasize that enough. And I really want you to think about what I've said earlier and in many of my previous videos. If you decide to use these methods and you get little burn marks on your casing, and God forbid something happens and you have to call your insurance company, you better remember that that casing is in your project. Because if it is, then the odds of you getting paid after they do inspection is virtually zero. And this guy, he takes no credibility to that at all. All he's going to do is keep doing videos, keep posting to make more AdSense money, and unfortunately, YouTube at this point just doesn't have the vetting process down yet. It's coming, and I can tell you right now, this is where if we are going to do an instructional video, not on an open genre that's basic and can't hurt anybody like painting, but when we're doing stuff with electrical and electronics, we have to be very careful. And I've getting guys said, well, you know what, if they're stupid enough to do what they're seeing in videos, then that's on them. Well, see, that's a pretty sad way of looking at things. And the truth of the matter is, we should be responsible. If we're truly going to step up to that level of an instructor, I feel, then show a process that is correct, show something you would present to someone else. Because again, these guys aren't doing that. This guy has probably never sold anything he soldered, and if he has, in the condition that we've seen here, it's pretty terrifying.
You can see here on the casing. There you go. That's what it should look like. When it gets bubbled or pooled or gets brown, I cannot present that to a client, nor would you want to accept it if you bought something from me. And you know what? You'd be damn right. That's the difference. That's the difference between a content creator pretending and someone doing this all the time. This is totally different. Does it cost me more money? Yes. But does it present a better product to my client? Yes. Do you expect that for your own projects? I assume you do, or you wouldn't be watching my channel. That's what you expect.